Alright, let's talk about the cutter and why this really doesn't work out so great. This is a 1-inch end mill with 8-inch radius on the bottom, which means this cutter is going to come down and cut into here, and this radius on that face is the same exact size as the radius of the cutter. And it's going to come around here, so in theory you would get a nice perfect 1/2-inch radius as you make your cuts. Now, when I talk about making engineering parts, we always talk about how things have to be tangent, or you can't have gaps in your geometry. You've got to make sure everything's touching at the same adjacent points where there's no overlap and no gaps. And that's all correct, but really it's important for the NC toolpath to not have gaps or discontinuity and tangencies. So I'm going to try and make a top view of this as if the cutter were drilling down into the part and machining this out to try and explain why a 1/2-inch radius wouldn't be that great if I want to use a 1/2-inch cutter. So I'm going to go into part design and create a sketch, and we'll do the sketch on the XY plane. And I will put that flat to the screen and go to rectangle. I'll just create a rectangle starting here, and we'll go up like 4 and 4. Okay, so there's your part. If this were my cutter and it were a 1/2-inch radius, okay, let's do this. I'm going to beef up the line weights. Let's beef it up just a little more so you can see. Alright, so there's the representation of the top of your part. So earlier we had created the pocket, but we didn't put the fillets in. And then this is a cutter that's going to be directly over the top of this pocket, if you will. Say we're 3/8 of an inch or 1/2 inch above the pocket before the operation started. I'll make this green. It's probably not the best color. Well, that's going to reference the cutter. Okay, and then we're going to come over here and cut it. So if this cutter were to go over here and start machining down here on this corner, say, the cutter is going to land here, and it would be a 1/2 inch. In reality, even if I had drawn it sharp edges, if I use a 1/2 inch cutter, you're going to get that radius there. Okay, so in reality, what we did was we went and put in 1/2 inch radius. Again, this is a top view of the pocket, so now all my radiuses are 1/2 inch. I'm going to go to auto search and go to properties. I'll beef them all up. Let's change that line color to something different. How about purple? See if that's visible. Okay, so this purple represents the periphery of the part. So here's your cutter at its start position. It's going to come over here, let's say. I'm going to have the cutter, it's going to come in, and it's going to fit perfect right there. And this is going to machine over in this direction. So let's say this axis represents the toolpath direction. Okay, I'll just create that. that means your toolpath will be like this. I would have to have gone purple. Okay, so your toolpath is doing 90-degree turns because your cutter is going to sit in here perfect everywhere it goes around. So this toolpath is going to define the center line of where the cutter is going to go. So it's going to be removing material, going deep, and it's also going to be removing material along the sides. So as it comes around the corner, you'll have a radius. But here's the problem. When we talk about the engineering part has to maintain tangency, we mean that the toolpath really has to have tangency. So as the toolpath wraps around here, what's going to happen is on these corners it's going to chatter. Okay, you're going to mar the side of the radiuses. So you don't want it to, it almost like it has to come in here and stop and do a 90-degree turn, stop and do a 90-degree turn. Since these are 90 degrees, that is no longer a tangent toolpath. The toolpath has discontinuity and tangency as it goes around, and that's what causes problems with the machine part. So I'm going to undo those. If I were to auto search this profile, there is a feature called offset. Why don't I see it? Offset right here. If you go to offset and I come in here, I'll bring this down in here. This offset would be a 1/2 inch offset. It just beat me, telling me, hey, I don't like this. The radius is zeroed out. There's no radius in there anymore. It just has discontinuity and tangent. In fact, if I try to offset that 9/16, it's beeping me and saying, hey, I can't, it's not good. I can't even go beyond the 1/2 inch. If I go to measure this, it's not going to like it. Okay, it's telling me, hey, these corners, I had to trim it off. So if I had offset it 3/8 of an inch, there's no problem. See, there's still corners around here. I know that there's, it's able to do that. The toolpath, if this were the case, the toolpath doesn't have any discontinuity and tangencies. That means that this line blends tangent to this curve, and this line blends tangent to this curve, and so on around. A perfect square has 90-degree turns in it, so it doesn't like that. So what would be better is if these radiuses were all 9/16. If you made the rate, what did I type in there? 9/16, which would be 56/25 really. Okay. So now your cutter would come in here. Let's do this. From this bigger radius, if I were to do an offset, so we'll do a auto search. Auto search is grabbing all the adjacent elements, and select your offset, and we come in a 1/2 inch this time. I know it's small. There's just a tiny little bit of radius there, not much of one at all. .0625. So as a designer, hey, why can't we have a 9/16 radius? What's the big deal? The the shop likes to try and grab as big a cutter as they can to try and hog out as much material as they can as fast as they can. So think of it as like this: when you go to pick up tools and you want to buy a socket set or a wrench set or drill bits, they come in fractions, right? Because we work in America, we work to imperial standards. You try and work to where the guys in the shop could use the most common tools that would be available, and your most common tools are 1/4 inch, 1/4, 1/8, 1/16, 1/32. Okay, so 9/16 radius would have very little effect on how the engineering part is affected, and make it a lot easier to just go ahead and grab a bigger cutter to go ahead and do that route. When I was in engineering, or when I was an NC programmer, if they gave me 1/2 inch radius, I just bumped their radius to 0.53, knowing that I'm still within engineering tolerance. So if I bump up the radius to 0.53, I'm still within engineering tolerance, and I can create a tool path that I know is just going to wrap around. There'd only be like a 0.03 radius, but it's enough to hold tangency, so I'm not getting stuck at one point and doing a 90-degree angle, because it's going to almost pause for effect when it hits that point and continue to go to the next line. It's not a good machining practice. So when you're designing parts, try and bear that in mind. So the fix to this part would be to simply expand your tree and open up your radiuses and change that to 9/16 or 56/25. And I would do the same thing for this one. And now I've got a part. I know that they're not going to have a problem with their 1/2 inch cutter and be able to wrap right around this. And that 1/8 inch radius on the bottom here is what creates that 1/8 inch radius as they're machining that out. All right, so those are things to keep in mind when you're making a machine part. If you have an opportunity to talk to your shop, talk to them about your design. They usually can tell you, hey, we can't really do that, or this would be better if you do it this way. You'll get information. You'll know how to go back and design your parts to help it make it more producible in the shop. All right. Well, I got another video for you all about pocketing at different depths, so go check that one out next.